morning. This is the 3rd of December 2024. We'll have 537th weekly Ocean's weekly seminar, and it is 157th international seminar. Today we will study for the case of Hawaiian monk seal entanglement data reveal the benefit of plastic debris removal. Today's presenter is Yening.
Hi everyone, this is Yanning from Taiwan. So today I will share this paper, 4 decades of Hawaiian monk seal entanglement data reveal the benefits of plastic debris removal. So first of all, because this year I had a chance to visit Hawaii, so when I saw this paper on science, I'm very interested in it. So thank you for giving me the opportunity to share this paper. So this paper, they examined the 40 years of Hawaiian monk seal entanglement records, and they compared the before and after removal efforts. And their data shows that a substantial reduction in entanglement rates where debris removal effort was most concentrated. And they also demonstrate that the large-scale and substantial removal of ALDFG can benefit the marine ecosystem. And this is they discover the potential to be transformational in restoration efforts. So this is the abstract. Okay, so this is Hawaiian monk seal. It is estimated that just 1,600 surviving individuals in the Hawaiian Islands, and this species is protected under the U.S. Endangered Species Act and also Marine Mammal Protection Act. And because the number of these animals is so low, so it is list endangered in the IUCN Red List. And since 1980s, to protect this animal is the priority for NOAA. So in this paper, you can see that the NOAA and other U.S. institution has put a lot of money to support the marine debris removal actions to protect this Hawaiian monk seal. Okay, this is another picture of it. So in those Hawaiian islands, it's normal that it's common to see this monk seal. They just lying and basking on the beach, but sometimes they will get entangled by the fishing nets or fishing gears. So in this picture, you can see that it's still alive and it's just sleeping, but you can see it because it has some interaction between the monk seal and the fishing gear. So it is urgent and necessary to remove this ALDFG. Okay, so this is Hawaiian archipelago. So the main Hawaiian islands, including Hawaii, Oahu, Kauai, these islands are at the east side of Hawaii. And the northwestern Hawaii Islands, you can see it's a series of small islands from Nihoa to Kure. So it's a very long series of islands. And in this paper, the study sites is at the northwestern Hawaiian Islands and mainly on the 6 islands: the French Frigate, Charles, Laysan, Desianski, Pearl, and Hermes Reef, Midway, and Cure. These 6 islands with the blue underlined. Okay, and the northwestern Hawaiian Islands is also the Papahanaumokuakea Marine National Monument. It's the biggest national parks in the United States. So you can see the study area is mainly overlapped with this Marine National Monument. And the name of the very difficult to pronounce, the Papahanaumokuakea Omokuakia is it means the mother of these islands. So in their legend, in the Hawaiian legend, these gardeners gave her love and body to create these Hawaiian islands. So they use her name and also her husband's name to name these marine national monument. And there are a lot of this is very important area, not only for the ecosystem, but also for the culture and heritage. So inside this national monument, there are more than 7,000 species of wildlife, 23 endangered species, and 14 million seabirds of 22 species. And also some green sea turtles, Hawaiian monk seals, and some coral reefs here. So you can tell, although it's very far from the United States, from the mainland, but it's very important. This place plays a very important role in the ecosystem and also in the wildlife protection. Okay, so this paper, they record 437 monk seals at 6 subpopulation sites, the 6 islands I told you before, from 1974 to 2022. And this record is mainly recorded by the US NOAA staff or their partners. And they found out that 76% of the entanglement is derelict fishing gear, and only one non-plastic entangling item is like a wire. So they want to examine the entanglement rate, and because the monk seal, the life cycle of monk seal, sometimes they live in the waters, and sometimes they come up to the beach for the basking. So they focus on the winged pups. This means the pup, the monk seal just get rid of their breasting mother. So, and they also found out the winged pups will stay near beachside and the water about 6 to 8 weeks. So this is a perfect period to observe their behavior and how if they are entangled by fishing nets. Okay, so talking on the marine debris removal. So since 1982, there are some small scale removal. It's mainly done by the NOAA staff. So when they record they survey the situation of monk seal, if they see some entanglement, they will try to remove the marine debris. And from 1996 to 1998, NOAA has set some limited experiments to evaluate the method to remove marine debris both on beach and in water. And from 1999, they start a large scale removal. So it's really large scale. So there will be one or more than one large vessels and a fleet of small vessels and trained divers. So when they approach to the coral reef, to the shallow water, the small vessels will be released from the large vessels. And sometimes the free divers will towed behind the small vessels to search for marine debris, and some trained scuba divers will remove the fishing net and other plastic fishing gears from the waters. So every year, until currently, every year they remove about 100 tons of marine debris. So it's really a large scale action to remove marine debris. Okay, so here you can see some photos of the removal actions. So not only at beach, but they also do removal from the water. Yeah, okay. Okay, so here we can see the marine debris removed from the 6 northwestern Hawaii islands. So from 1996 to 2022, a total of 945 tons of marine debris was removed. And when you see the graph at right-hand side, you can see the blue line. The blue line is the removal in Pearl and Hermes Islands. So you can see in just Pearl and Hermes Islands, it's already removed like almost half of the 545 metric tons. So in Pearl and Hermes, it's nearly 500 tons. And in the first 5 years, so from 2000 to 2005, you can see at this blue line, they already removed 300 tons. So it's the volume is quite massive compared to the removal action in other islands. And the second large amount is at the Midway Island, the pink one. So you can see under the green line, you see the pink line. So the pink line is also a lot, like 200 tons in the past 26 years. So these two, the removal action in Pearl and Hermes Islands and in the Midway Islands occupy like more than half, or maybe 60 or 70% of the total removal amount. Okay. And you can see the map I put at the left-hand side. So the Pearl and Hermes Reef and also Midway, they are more at the western side of these northwestern Hawaii Islands. Okay. And this is, I just mentioned, the largest amount, more than 500 tons of debris was removed from Pearl and Hermes Reef. So this island I circled in red is at a very remote area, and they removed a lot of debris from this island. Okay. And so the research team want to test whether the wind pop entanglement rates differed before and after large-scale marine debris removal. So I just mentioned that the large-scale removal action starts around 1999. So they used 2000 as a boundary. So before 2000, they define as the pre-debris removal, and from 2000 to 2022 is post-debris removal, and they use Poisson regression. So Poisson regression is a generalized linear model form of is a kind of regression analysis, and it's used model count data and contingency tables. So in this case, in this study, the count here is the qualifying wind pop entanglements, and they put the observed wind pop exposure days. They use log of these exposure days as an offset, and the independent factors include subpopulations and pre and post debris removal. So they used Poisson regression to test if the wind pop entanglement rates differed before and after large-scale marine debris removal. Okay, and to evaluate which model is best fitting their assumption, so they use the archaic information criterion, the AIC number. So to examine which model performs the best, the one with the lowest AIC number is the best fitting model. So in our case, you can see the first two, they have the lowest AIC number. So their models is the best fitting number. So these both two models, they both included subpopulation and debris removal effects. And the difference is very little. You see just 1.3 of this AIC number. So these results suggest that entanglement rates differed statistically among subpopulation and were lower after debris removal, but also suggest that removal effects may have varied in magnitude with subpopulation. Okay, so I will go to next slide. So this one you can see the before and after removal. The entangle rate of monk seal before and after the debris removal. So the at Pearl and Hermes, you can see there is a huge drop of the entanglement rate. So here is they put a significant star here. And in other islands, most at the islands, 5 of 6 of the islands, you can see after the debris removal, the rate has dropped. Only at Layton, there is a small increase. So from this figure, you can see that at different subpopulation at different islands, they are like slightly different, and this may relevant to the magnitude. So you can see the number of entanglement, the change of entanglement rate here. Okay, so here is from the supplementary material. So here you can see more clearly. So they use this Pearl and Hermes reef. So you can see that after the removal action, it has dropped 71%. So it's really a big difference between the debris removal action. So we can tell that the debris removal is effective to reduce the entanglement of monk seal. Okay, so here I go to the discussion part. So they conclude that a sufficiently intensive and sustained marine debris removal program can effectively reduce wildlife entanglement hazard. And at Pearl and Hermes Reef, they also discuss why the action at the Pearl and Hermes Reef is so significant, much more significant than than the removal at other islands. So they think because the first is a relatively high baseline entanglement rate prior to debris extraction efforts. So before 2000, before the debris cleanup, there is already a high entanglement rate. And at the Pearl and Hermes Reef, the amount of debris removed is also higher than other and other islands. And in the early cleanup, like I said, in the early, like 5 or 6 years, they removed a massive amount of marine debris from the Pearl and Hermes Reef. So maybe it's because of they removed a lot of accumulated debris, so it reduced effectively of the entanglement of Hawaiian monk seal. So this is what this paper about. Is there any question?
Thank you, Yanning, for your presentation. And we will have discussion time. If you have any questions and opinions about this paper and these issues, please tell us plainly.
I can share some photos of their removal action with you. So it's mainly done by an NGO, a local NGO. So every year, like this year, they set 3 expeditions to these northwestern Hawaiian islands to do the removal. And each expedition may be from 3 weeks to 4 weeks. So it's really labor intense work. So you can see this is what it's like a huge amount of what they clean up from the remote islands. And there are quite a lot of fishing nets and ropes entangled on the beach, and also sometimes also entangled of coral reef. And you can see a lot of baby birds, baby albatross near their at the Midway Island. So they just removed the fishing nets from the islands. So not only monk seal. Monk seal is the most easiest species to record, but in this area, because of so many kinds of wildlife, like seabirds, green sea turtles, and also other species. So the debris removal action is not only benefit for the monk seal, but also benefit for other species in the Hawaii Islands. And you can see it's other kinds of seabirds here. Okay.
Thank you for sharing your photos. And as I told you, if you have any questions, opinions, please share it.
Thank you, Yanning. And I want to point out that the later part of discussion,
Okay.
there is a discussion on IUU, illegal, unreported, and unregulated fishing may contribute a lot to the generation of direct fishing gear in this area, or also including Pacific or all the ocean of the world. So the authors pointed out that we need more regulation on IUU to reduce TFG. And I have one question.
Okay.
It's kind of a statistical thing, so I do not expect we can get clear answer from this discussion. But in this paper, they use AIC for finding out the significant model.
Yes.
And they find out that when they include the Pearl and Hermes leaf, the AIC number decreased over 2, maybe 3. And they decided that only this factor is significant. So they say the debris removal effect is significant in Pearl and Hermes leaf. But usually we report p-value to find out the significant factor in our model. But in this case, they are using AIC number. It is not familiar with me. So do you have any idea why they use this kind of approach?
I don't really know. This is like out of my expertise. I really have no idea of it. Is it because they use the Poisson regression is one of the linear, the generalized linear model is because they use they want to test multiple factors, so they use AIC to examine. Is this the reason? I'm not sure about this.
Yeah, I think so. But usually AIC model is utilized when you try to find a best model. Lowest AIC number means best model, best fitting model.
Yes.
But the significance is other thing, but they do not report p-value or other thing. But we have a clue in supplementary material, the next table. Yeah, the delta AIC with a gray shaded part, Pearl and Hermes leaf, the decrease of AIC is 3.32. It is much higher than other variation. And I asked ChatGPT why they use this approach. It told me that when you found out that the decrease of over 2 AIC, we can say that it is significant, but I could not find any reference or evidence to explain that approach. But with the common sense, we can understand, Pearl and Hermes leaf is has a most significant effect for this model. So we can safely say that this is a significant factor or factor, but I'm not sure how we can explain this statistical approach. But anyway, this is a kind of a simple way to show the people how this kind of counter data can be analyzed by statistical model. That's it.
Yeah, thank you. I also not understand of this delta AIC thing.
I would like to mention for the point, and when you see figure 4, we can see Paul and Hermes. They show the star. So I think they omitted explanation for this. Maybe Paul and Hermes difference determined by entanglement rate and between pre-removal and post-removal, and we can get p-value as Jung-Myung said, and the difference observed only for Paul and Hermes, not by AI's value. So they said for this site, the difference is significant. And the AI's value is different, as he said. So I think they omitted explanation. This difference from other statistical analysis, like mean, the average value. They compared the average value for between pre-removal and post-removal, and they can get p-value, and they can determine the difference is significant or not. This figure made by that statistical analysis, and when you see the figure 4, the caption, they didn't tell about the AIS value. So this analysis is different from GLM, and the supplementary table. The table is from GLM and AIS value, and for that side, the difference is significant. Different. The removal. What is that? Yanning, please show us the table. 71% decrease. Yeah, this is when you see the entanglement rate between pre-removal and post-removal, the difference the significantly reduced. We can understand, but as Jong-myung said, it doesn't mean the significant difference. Doesn't means for my understanding, it doesn't say about the significant difference or not. But common sense, maybe. Yeah, it's significant difference. So they omitted the explanation for figure 4. I think this is the average comparison, like classical loss or.
I don't think so. Yeah, I'm not sure.
That makes sense because the difference can be comparison can be said from the p-value, and it comes from Wallace and all critical errors.
I don't think so, because this is science paper. They should report the method, statistical method they use. If they use that kind of statistical method, they should include it in method part. But they only said they use Poisson regression model with the GLM. I believe they use only GLM with the Poisson regression model.
We cannot get from the GLM. We cannot get this kind of figure, and we cannot determine that point.
Maybe
figure 4.
Maybe.
So it's weird point.
Yeah.
It should.
They should.
This weird.
Yeah. They should explain how they generate that picture. Okay.
What not clear to me is the line below the Pearl and Hermes, the Ziensky Islands. It's also 71% decrease.
Mm-hmm. Yeah. So they should explain how they generate figure 4. Figure 4?
Yeah, I agree.
And one more thing I want to point out is they said this Hawaiian island cleanup is world's largest in-water DFG removal with 2 references. But maybe the world's largest would be in Korea.
Mediterranean project.
Maybe. Yeah, but I want to check the reference, but there is not that clear evidence that showing this Hawaiian island DFG removal is world's largest in-water DFG removal. We have to check it later.
Yep.
Okay.
Thank you very much, Yanning, for the introduction of interesting paper. For understanding the participants' understanding in this seminar, I would like to add some points about this paper. Actually, entanglement rates only can be observed by the people, so this not exactly same that really happened around the area. So maybe Pearl and Hermes Reef has a higher number of entanglements in this paper, but some other areas can be also affected by entanglement. So we need to understand about this when reading this kind of paper. That is the first point. The second point is that in this paper, they cleaned up a lot of fishing gears from seawater or beach. Those are mainly originated by other countries like Korea or other
China, Japan.
China, Japan, absolutely Taiwan or Japan. So the cleanup fishing gears from sea, usually we say that kind of activities are reactive measure after something happened. But in this case, those are preventive actions to protect animals from DFG, dealing fishing gear entanglement. So they try to remove the fishing gears from seawater or beach before those can affect the animals. So we have to understand about this. And they say the authors say 76% of entanglement were caused by fishing debris, including fishing nets and ropes, and also probably eel trap gears, eel traps. So actual preventive approach should be taken in other countries like Korea, Japan, China, and Taiwan. So in our case, we OSEAN implement 10-to-1 campaign, which consists of fishing gears such as ropes and eel traps to reduce the current status to 1/10 level of pollution. So those kind of approach can be real preventive actions. So those are my points.
Thank you, Sunny. And okay. Bye-bye.